programming language can implement this issue. So step 3, the coding, is going to be a lot easier if step 2 is done well. Does that make sense? If you do a good job planning, the coding is going to be clear. Now, there are some issues with coding. First of all, there's lots of languages, and we'll talk briefly about that, okay? There's lots of different programming languages, okay? Let's talk first about compiling. What does it mean when I say that a program is compiled? Okay, so that is definitely one of the roles of a compiler. The answer, he says, is checks to make sure the syntax is correct. So one of the roles of the compiler is to check to make sure the syntax is correct. What else does the compiler do? No, that's your job. Yes. The primary role of the compiler is to translate the programming language to machine language so the computer can execute it. And in the process, if there's syntax errors, those have to be corrected, because it can't do it if you don't follow the rules. So let's say that again. So the primary role of a compiler is to translate from a programming language to a machine language that the computer can execute. We're going to talk a little bit more about that, okay? Now, what is an editor? What do you think an editor does? Just allows me to type the code. It's a little bit like a word processor, but doesn't have as many as much features. An editor allows me to type in the code. And we'll have one that we use in Visual Studio that is provided to us, okay? We'll edit or type in the code, okay? Now, there's another phase that we're going to talk about that comes together with compiling. The goal of this is to translate your program into an executable program, meaning what? What does it mean if a program is executable? It'll run on the computer. It'll run on the computer, execute on the computer, okay? So this is the coding phase. Now, step 4 is called the testing phase. This is very important. Very important. And because of the level of importance, many times there are separate departments in a company that just test systems. My first job out of college was writing software for the racetracks. And I know it sounds cool. Here I am, right? But we did wagering systems, and we also did the lotteries. And we wrote entire systems for going to a racetrack. You had betting machines, and you had the board that displays the odds and the winnings. And then, of course, you had an overall system back end that calculated the wins and ran the races, and et cetera, with an operator. Now, we would write the code, the programmers would all write, and before we shipped it into the field, we gave it to a department in our company called Quality Control, QC. We hated them, okay? Because they would sit there with their clipboards. They would actually emulate, one time we even went down to Timonium Fairgrounds. They would sit there, they'd run through the races, the day of races, they'd print the tickets, they'd go through everything beforehand before it was shipped to the actual racetrack, which could have been in the US, could have been in New Zealand, wherever. Why is QC or some testing component so essential before you ship it to the field? Yes? Got to make sure it works right and it's user-friendly. And what are the implications if it doesn't?
Well, they would ruin the whole race if they want.
Yeah, I mean.
Cheating in the system.
Okay, so since we're using the example of a racetrack, first of all, you're talking a lot of money. Okay? So if there's an error, this could either allow the user to be screwed out of a lot of money, or could allow the racetrack to receive too much money in, which has legal implications. Okay? So there's a lot of legal implications to the actual payout and odds of a race. Okay, what else? What else besides the fact that you could lose money? Yeah. The answer was you could lose business. So let's say you go to a racetrack and it's not working all day. I mean, you may not go back to that racetrack for months or years, and people may never go there again. So in addition to losing money and having legal issues, you could hurt your reputation and lose business. Now, the racetrack is not particularly, I can't think of any lives that could be lost in that example, okay? But what about if it's something like an airplane, a navigation system for an airplane? What's different about that testing? Who can talk about that? Yeah. Okay, so this is not just like, let's cross our fingers and blast off and see what happens, right? Because not only do you have money and legal implications, but lives are at stake. So what is, in this phase, in the testing phase here, QC is not enough. What do we need to do for some type of system like that in the testing phase? I know you know. More phases to the testing, but what do we call that when we do extensive testing before we put something actually in the field because of the loss of life or the loss of expensive machinery? So how many people have heard of simulations? So simulations could be another millions of dollars of programs that just test the system that we wrote. Does that make sense? So simulation takes place in this phase if it's if that's absolutely necessary for things that, like I said, have lives or expensive machinery at stake. We don't just cross our fingers and hope. This would not be a good testing philosophy. So this phase can be as simple as running a few sets of data, or it could be a multi-million-dollar simulation phase. Does that make sense? That's the point I'm trying to get across here. Okay? Now, we call this phase debugging, which is essentially getting the bugs out of the program. Okay? The type of bugs or errors that occur at this time are called logic errors. So can somebody explain the difference for me between a syntax error, which occurred in step 3, and a logic error, which we detected in step 4? Yeah.
Syntax error would be like it would be able to read it because it's not right.
Okay, so the syntax error is something that cannot be read by the compiler. So the compiler notices a syntax error. They're annoying. We'll see lots of syntax errors in the labs. They're annoying, but they're basically saying, I can't translate because this doesn't make sense. Okay? As opposed to a logic error. Somebody wants to add to that?
Syntax is more like the equation isn't right, so it can't mathematically solve it, versus logic error, which is it doesn't make sense in general.
Well, actually, a lot of okay. So the answer is, again, to repeat for the mic, the logic error is an equation that would be an error. Actually, I mean syntax error. A syntax error is any violation of the rules of the language. And this typically means things like you left out a semicolon, you misspelled something, and the compiler, as annoying as it is, stops you and doesn't allow the program to compile or run. A logic error could very well be a formula mistake. You could have subtracted rather than adding. You could have left out a parentheses and had the equation gives you the wrong answer. This is a very common logic error. This is not told you by the computer. Instead, this is found when you're testing. Okay, does that make sense? A logic error is something it's running, it's not running correctly, it failed a test. This is something that you did incorrectly in the logic of the program. Okay? It could crash. Some logic errors cause you to crash. Okay? But basically compiled, and a lot of people think, especially beginning programmers, that if they compiled, yes, they're done, they run out the door, they go to lunch, la, la, la. That doesn't mean your program works, okay? Just means it followed the rules of the language. The logic errors means the programs did not work correctly. And the only way to determine this is to do a lot of testing. Now, the word bug sort of has like a story behind. There was, they used to keep logbooks. You know, in some of these larger computers, people would man them around the clocks, and they would keep a logbook and write down what they had done, la, la, la. Well, one day, they were having issues where the computer kept having this random error, which if you're a programmer, random errors are the hardest to fix. Because if you can't duplicate it, it's really hard to fix. I always hated those kind of errors, you know? If you can duplicate it, your chances of fixing it are very good. But if it happens randomly, it's very difficult to fix. So anyway, they kept having this random issue, and somebody went behind the computer, and there was a moth flying inside the circuitry, and it was short-circuiting, you know, the machine. So they took the moth, they taped it to the logbook, and said, found this bug. So for some reason or other, they now call many logic errors, they call them a bug in the computer. From that's the story there. Now the fifth phase, okay, if you've recently bought a software program, one of the parts of this phase is documentation. And if you've recently bought a software program, how nice and wonderful is the documentation? Not, right? So do you think the problem is because this is the fifth phase, they ran out of time? Possibly, okay? The other issue is that engineers are known for their tremendous logic skills, mathematical skills. What about their writing skills? Not, okay? So this is a part that oftentimes gets the short end of the stick. So documentation, back to my job for when I was working for the racetracks, we needed a lot of documentation because you had to have it for the operators. They needed to know exactly what, you know, tests to do at the end of the day and reports to run. And we actually hired out-of-work English majors to write documentation. They were called technical writers. So there was another department that, you know, did this type of documentation, okay? So that may or may not be done by somebody other than the programmer, okay? What do you think I mean by maintenance? What do you think I mean by maintenance? Yeah. That could be one aspect of maintenance, fixing exploits, yeah. Yeah, that's a big part, you know, keeping things up to date. So when you write a large system, it's not going to be, that system could last 20 years, scarily. You know, that's kind of scary, isn't it? Could last 30 years. Some of our banking systems have been in existence for longer than that. So maintenance means changing programs so that they work with existing issues. And I'm going to throw out a figure, and I always hear this figure, and I don't know what. 80% of programming is maintenance. So most likely, when you get a job as a programmer, yeah, you got a job, you will be changing existing code, not writing everything from scratch. Does that make sense? So maintenance, it could be a really big change, or it could be small changes, but it's changing existing code. And that's a very important part of programming, okay? Now, let's go back to this a second. Where do you think most of the time is spent in the software development lifecycle? Yeah, okay. Unfortunately, most time is spent testing, which translated means fixing, right? It's not a good thing, okay? So a lot of time is spent here, and this is why you don't do a lot of documentation and maintenance here. Where, let's rephrase that question, where should most of the time be spent? You know, well, analysis and design. I mean, if you don't do a good job figuring out the problem and planning, this is a life lesson. This does not just apply to software development lifecycle, right? The more time you spend up front planning, the better the results are going to be, okay? So, although many people would like to do this,